Hey everybody, welcome back. So today I'm looking at the natural trumpet patch that was featured in the most recent version of the Analog Waveguide manual released by Chair. The idea is to simulate the way a trumpet naturally resonates at various overtones of its fundamental frequency. To do this, the waveguide is set to some fixed pitch that represents that fundamental, and then its feedback path is routed through a filter that's set with a fairly high resonance. In this case, I'm using the left channel of the Weston Precision Audio SF1. I have it set to low pass mode with a 24 decibel per octave slope, as I found that low pass filters with fairly steep slopes tend to work the best. Then I'm sending pitch CV from the zero control to the filter, and as the filter cutoff then changes, it's going to pick up on various overtones of that fundamental frequency. And that's how you make some music. Now, the feedback knob on the waveguide is currently down, because if that was turned up, you would just hear continuous sound as the filter is resonating with the current harmonic. So to control the sound, you need to send an envelope to modulate the feedback. So I have an ADSR envelope off screen that's coming in here and being triggered when I press a touch plate on the zero control. So let me show you how the filter steps through those overtones by turning this up and sweeping the frequency a little bit. So you can hear that kind of does sound a little bit like it's bending in between, but it doesn't just move smoothly through all the different frequencies, it jumps a lot. So it really wants to find a harmonic that it can stabilize on, and as it gets further away from the last one, it'll get a little unstable, warble a little bit, but then it'll suddenly jump to the next one. Now, just like with a real valveless trumpet, it has a limitation that you can't just move stepwise through the notes of a scale. You have to progress through those overtones as they naturally occur. So you can't set up this patch and then just easily play up and down a few octaves on a keyboard. It's actually a bit challenging to make this work in a musical context if you want to be able to just play kind of arbitrary notes that fit in with some other music that's playing on some other voices that you have. In fact, when I originally was experimenting with this patch, I was using the KeyStep 37, and I found it pretty challenging to tune. So even when I adjusted the waveguide and the filter so that I got, for example, a C key on the keyboard to actually produce a note that was in a frequency corresponding to C, then as I played up the keys, even as I hit keys that were hitting real overtones, they didn't always correspond to the note on the keyboard that I was playing, or if they did, they were often quite out of tune. And now there's a perfectly natural reason for that, and that's just because those overtones don't follow the equal temperament divisions that we normally use. So in modern music, typically a keyboard instrument is tuned so that every note on the 12-tone scale is just exactly 1/12 up from the previous one of the octave. But that's not how harmonics work. So perfect fifths and thirds and so on, they don't actually line up with those 12ths so exactly. And so producing these overtones is just not going to fit into a keyboard like that. So I switched to using the zero control, which it's kind of well suited to this because it has these pitch knobs on the top that you can individually tune however you like. And so what I did is I just found kind of an arbitrary root note that I wanted to start with, and then I just adjusted the knobs until I hit a nice overtone over that original root note. And so I got something approximating a kind of major scale. Although, looks like I didn't quite get this back to its original position. There we go. So it's a bit sensitive. Even a little bit of difference can change one of the notes, as you see, because as I said, it's trying to stabilize on an overtone, and if you shift even a little bit, you might cause it to shift to the next lowest one or next upper one, depending. Now I also have a little something else going on, so you might have noticed the tuner, and that actually these notes do seem particularly well tuned to an equal temperament scale. And so you might be wondering, well, how did he do that? Well, it's pretty simple. So in essence, I'm kind of cheating. So if you think of the waveguide set to a certain pitch as representing a trumpet of a certain length, that would then naturally produce a certain note. Well, what I've done is I've taken advantage of the fact that the zero control here has multiple rows of knobs that can send out a control voltage. And so I'm using the third row here. It's going into the FM input of the waveguide. And I've turned that up a little bit, not too much, because I wanted fairly fine control. And so originally I had these all tuned, as close as I could get them according to the natural overtones. But in order to fit them into an equal temperament scale, then I adjusted these up or down as needed, essentially kind of adjusting the length of the trumpet so that I'm changing the fundamental of the trumpet so that the corresponding overtone then shifts up or down a little bit. So I think it's a nice little trick that you can do with something like the zero control that you wouldn't really be able to do so easily with a standard keyboard. On the other hand, you're limited here to only 8 notes, but what do you want? Everything is a trade-off. Let me show you what it sounds like without that adjustment going on. But of course, it's going to sound worse than it could sound, because it's not so bad, but this one, it's a bit off. But of course, without that adjustment, then I'd want to retune these so that they actually hit the natural overtones a little bit more exactly. Some of them are a little bit off. So those natural overtones, sound very nice. I mean, they are harmonious. That's kind of the point, right? They're in nice ratios with the fundamental. But as I said, if you want things to fit in with other voices that you have that are playing according to an equal temperament standard, then that might cause some issues. So that's one possible solution. Another thing I considered trying is I recently acquired an Expert Sleepers FH2, and it's able to load custom scales. So you can have it send out pitch information according to any kind of micro tunings that you like. And so I thought maybe I would experiment with that in trying to load a scale into it that would correspond to that overtone series and see if I could get it to just play nicely up the keyboard every overtone. But that'll have to wait for a while because I'm still learning how to use the FH2. So let's get back to this patch and explain a few other things that are going on. Of course, the rotation modulation is up a little bit to give it more of this metallic character. Without that, it's very mellow, almost kind of like an organ tone. It's just like a sine wave almost. So if you don't recall or you haven't watched other videos on the waveguide, you might not know, but the rotation modulation here, the input is normal to the X output, so the strength of the X signal will determine the amount of rotation. And so, and again, the rotation is sort of mingling the X and the Y feedback paths so that you get sort of more complex harmonics. And so that can give it this more brassy sound. It still sounds pretty mellow, which I think has to do with the filter. So this Weston Precision SF1 seems to be very, very clean, I guess you could say, in its resonance qualities. So I don't think it's imparting all that much character to the sound. Other filters might do that differently. In fact, I'll try to show you a little bit of the Belgrade in a minute. Turning this rotation modulation up more, you can get a bit of a brighter sound. But different notes will have slightly different characters just based on the fact that they're resonating a little bit differently, I guess. And if you hold them down too long, well, these all sound pretty good still, but if I go a little bit higher, then you start to get that kind of electric feedback. That sounds pretty nice, though. Now, some other issues. There's a tendency, you have to be a little careful with the like the release time and how fast you play, because there's a little bit of a tendency that if there's still something in the feedback loop before this completely closes down, it will have a tendency to dominate. And so, for example, between these two notes, if I play them too fast, then you won't hear the pitch change so much. And you'll get some weird interactions and some kind of chaotic sounds there. Like right there. It just sounds like the same note if I play them too fast. So that's something to be aware of. And that also affects when you're trying to tune it. If you're tuning the cutoff frequency and you get it to a point where you have a note that you want, you think, oh, great, okay, I got that F5 or something, perfect. And then you let go, and then you trigger the note. It might actually be a different note now, because it might have just been hanging on that F5 because you passed that by, and it was kind of dominating the feedback. But then when you let the feedback die and then re-trigger it, it's resonating at some other frequency. So, bit of a challenge. You have to be a little bit patient. That's basically the patch. It's not that complicated. The Y channel here just gives it a bit of a fuller kind of brassy sound. So if I turn down on the mixer here, we get a sort of square wave fluty sound without the Y channel. Now it's still mingling in the feedback, of course, from the rotation, but we're not getting the main Y signal. Sounds a lot better with the Y in there. Okay, so to finish up, I just want to demonstrate how different it can sound with a different filter. So I think the filter that you use is going to crucially impact what you're able to do and what it's going to sound like. So if I just move everything over into the Belgrade. Now this is a so-called dual peak filter, but with the filter set to low pass and the span turned all the way down, it should be a 24 decibel per octave low pass. And so it should be similar, at least, to what I was getting with the Weston. But what I found is that the scale that I tuned to the zero control that works with the Weston just absolutely does not work the same way on the Belgrade. And that's not just a matter of, oh, the knob is in the wrong position. In fact, I just have found it impossible to get that particular starting note, which was a G sharp 3. It seems to just kind of skip from F sharp up to A. So I was playing with the Belgrade earlier and I was able to get some nice sounds out of it, but I just show you this to make the point that if you use a different filter, you'll have to adjust everything kind of differently to work with that filter. I feel like the Belgrade does have a little bit more character that it's imparting to the sound, on the other hand. Even though right now I don't have it playing anything remotely melodious. One other interesting thing about the Belgrade is this self-modulation, cross-modulation switch here. With that earlier, I was getting these kind of reedy sounds that were almost more like kind of like an oboe or something. But I'm not sure I can make that work right now. Also, by adjusting the span, you can get some more potentially interesting harmonics too. Well, anyway, I think that's enough for now. So that'll do it for this video. As always, thank you for watching. I hope you enjoyed it and found it interesting. If you haven't seen my other videos on the Analog Waveguide yet, check out my channel because I've got several of them. And of course, I will be making more in the future, so consider subscribing if you'd like to make sure that you see those. Thanks again, and enjoy the rest of your day.